The screen is visible now. We have seen functions. Functions are the features which are provided by any of the programming language which makes the program modular. That means it permits us to divide the program into smaller units so that they can be handled very properly. And other aspect is the most important aspect of this is we can reuse the code number of times. So we can put it in a loop. We can call that function for various different values or inputs. But that code can be reused a number of times. That's why the function is used. That we have seen many of the things in the past lecture. We have also seen two examples where we were not passing any arguments or parameters or nor returning any value. In this particular function, we have a function called as sum, which is just called in the main function. It is directly getting executed and is printing something. So it has no argument and no return value. Whereas we have seen another example which had a return value. So passing the argument and collecting the result is needs to be handled very carefully and very crucially because that's the way a function is going to operate correctly. You can see here we have not passed any argument, but sum is called. Sum is called, and when I define sum, it has a return type. Return type of sum is integer. That means sum is going to return some integer value to the calling function. It is going to give something back. So if it is giving something back, we need to have a collecting container for it. So in this case, if it is returning an integer, an integer container will be defined for it. So unlike previous program, here you can see sum is directly called and there is no collection. Okay, there is no collection of any variable. Sum has value, nothing, no value to return, or some have a return type void. Whereas here some have a return type integer. That's why we are taking help of this variable to collect it. So here also you can see it has a return statement, return a plus b. Whereas in the previous case, we don't have any return statement. Default, it is going to return the control to the calling program. So this it is not only returning the control, but it is returning a value also, which will be collected in sum. So this thing, carrying forward the discussion with this theme, we'll have a small example, a function with arguments and will not return a value. Function with arguments and with no return value. Argument means the parameters. What are parameters? Parameters are the input provided to the function on which the function is going to work. The variables with the values which the function is going to process are called as parameters. They are also called as arguments. Okay. So whatever example, whatever analogy we have seen, you are giving your vehicle to the mechanic. So mechanic is a function, you are a calling function, and your vehicle is the argument or a parameter on which the function mechanic is going to process something or work on it. So here, this example, what we are looking for is an argument to argument and without a return value. It is not returning a value. So that's why the data type is void. But you can see, unlike previous definition, here the sum is having a list of parameters with it. As it is only a declaration, what we are intimating that there will be a function named as sum, which will not return anything and which will take two integers as the parameter. Okay. So what care we need to take is, whenever this function is called, there must be two parameters passed to it. Okay. So what's happening here, we'll see. A, B are declared, result is declared but is of no use. then it will this statement, it will print this statement, and it is going to scan two variables A and B. Let us say that we are entering 10 and 20. Okay. Now sum A, B. What will happen? Compiler is going to check whether such function is in existence or not. So it will just check out this declaration statement. Yes, there is a function by name sum. There is a function by name sum which is taking two integer parameters. Is it? Yes, it is taking integer parameters. A and B both are integers and is not returning any value. So this call to a function sum is done, but the input A and B. Now what next will happen is the control will go to this statement. Control will go to this statement, and value of A will be copied in this variable, and value of B will be copied in this variable. Okay. These variables are again named as A and B. You can name anything. Even if I am saying it as X, I am saying it as Y, it is going to make no difference. Okay. So what's happening? The value of A, this value will be copied in the first variable. This value will be copied in the second variable. And now I can use these variables for the processing in this program. So now 10 will be, this A will be 10, this B will be 20. And A plus B is going to return 30 or print 30, not return, sorry. It is not returning anything. So this total will be printed. Remember, one very important thing. This A is the part of main function. This B is the part of main function. Whereas this A and this B are the part of sum function. Okay. So this A and this A are not same. They may hold the same value, but they are not same. As I said earlier, you can name it as X and Y. There is no difference. Okay. So the first AB are the part of main and second AB are the part of sum. Okay. So this thing we need to take care of. So have you understood? This is not returning any value, but it is taking an argument. These are the parameters which are passed to sum, which will be processed. Here they are added. It can be anything. It can produce any other result also. But right now they are not producing any other result. They are just printing a total of A and B. So this is a function with argument and without a return value. The last thing which we'll see is the function with argument and with a return value. This is the last example for the basic functions we are taking. Now we are trying to define a function which will take a parameter and will return something. Okay. So now the declaration changes. There is a function sum. There will be a use of function sum in the program, which will take two integers as argument and will return an integer value as argument. Now, whenever sum will be called, I must make sure that it will take two arguments. Both should be integer, and it will return an integer value, so it must be collected somewhere. So the syntax will not be similar to the previous one, because in previous case we were not returning a value. Now we are trying to return a value. So in this case, A and B are declared. Result is declared. These two statements are printed. This is going to take A and B value. Now what's there? Now we have a function called sum. Result is equal to sum of AB. We'll just check out whether sum is in existence or not. Yes, there is a function called as sum, which takes two integer arguments, A and B. Yes, it is taking, and so it is returning a value integer, which is getting collected in result. which is getting collected in the result. So syntactically the thing is correct. Conceptually the thing is also logical. Okay. Now what will happen after calling this function? If this control will go here. Control will go here. A value of A will be copied in this new A. Value of B. Value of B will also be copied in this, which is the value which are scanned. Okay, A will be copied here, B will be copied here. Okay, so let us again say that A is 10 and B is 20. So now this becomes 10 and this becomes 20. So in the previous example, we were directly getting the sum, but in this example, what we are doing, we are adding them, forming a variable, forming a value, and this value is returned. Now this value is returned. So while returning the control, it is going to return 30 to this place. So it will become 30. Okay. Result in previous example, the result was directly printed, no value was returned. In this example, the value is returned, and now result is a local variable for main, so it can be used further for any further processing. So we are printing it here. Output of both the programs will be same, but the previous example was not returning a value. This example is returning a value. So I hope I made this idea clear. Shall we proceed? Today we have a double strength in the class because I've combined section A and section B together. So we have more than 100 people. So is it okay? Shall we proceed? At least prompt in the chat box. Fine. There are two types of functions. One are standard library functions and other are user-defined functions. So the standard library functions are the functions which we are using. Your printf, scanf, getch, clr, or some functions from math.h, that is POW or sum or something like that. So some standard library header files are in existence in C, and those header files contain some library functions. We just need to include that header file, and we can call any of the functions which is defined in that particular header file. So even printers, scanf are also the functions, are the standard library functions which we are using. So as and when required, we can just import or include that header file and call all the functions which are predefined. So standard library functions are predefined functions. We don't have any control on that. Only thing which we can have is we can pass the argument to that and get the result of it. But we cannot alter that. We cannot define that. Okay. These are all default functions which are defined. What's there in our control is the second type, user-defined function. Here, the user themselves define some functions which will specify the task which the user wants to get performed on a particular input. So user-defined functions are the functions with which we are right now dealing. Okay, so there are two functions: standard library function and user-defined function. Remember, the function standard library function can call the user-defined function, and user-defined function can also call the standard library function. So they are helping each other to get executed. Only thing is, standard library functions cannot be heard by us, cannot be defined by us. The user-defined functions can be totally designed by us, defined by us, but they cannot be standardized. They will be in existence only for that particular program. Once the program is over, function is over. Okay, it cannot be used as a standard function in all other programs which we are referring. So we are defining with we are dealing with the user-defined function. Now we'll proceed further in this the arguments, function arguments or function parameters. If a function is to use some arguments, it must declare variables that accept the value of the argument. Okay, that means we need to have some variables which will generate the value in the calling function, and we will have another variables in the function which will collect those values. Okay, so if I'm giving something, we must have a container to collect them, and a vice versa also. If function is returning something, we need to have a container to collect it at the calling function. So these variables are called as formal parameters of the function. So in the previous case, as we mentioned here, a, b will be the formal parameters of the function in this case. And formal parameters behave like other local variables inside the function and are created upon the entry of the function and destroyed upon the exit. So their life is only limited to that function. It will be created when that function is called, or function is in execution, and it will be destroyed upon the exit. This creation and destruction of the variables is aspect which any programmer needs to know, because we create a number of variables during the program execution, and most of the time these variables reside in the memory even after completion of the program. Reside in the memory in the sense they are absolutely useless because program execution is over, but they have accommodated some memory space and they will continue consuming the memory space. So at that time, most of the time, when other program is getting executed, the free space need to be searched, and some fragments also get created. So in the further programming, when we'll understand the dynamic memory allocation, we will try to create the variables during the program and also destroy the variables once the program is over. We'll not keep it in the memory till long, because we'll have to bother about the usage of memory in the program. So the function arguments created upon the entry and destroyed upon the exit. So the word I have used here is local variable. There are two types of variables or scopes of variables. There are two types of variables: global variable and local variable. Local variables means the variables which are declared within the function and are used within the function. Are declared within the function and used within the function. But that means they cannot be used in any other function. They cannot be used in the calling function even. Like here, what we can is here you can see, as I said, A, B are the variables which are declared in main and are also, these are formal arguments, are also declared in sum. But these two variables are different and these two variables are different. This A is different, this A is different. They may hold same value, but they are not same. Okay, there will be two separate blocks created for two different A's. Okay, this will be a from main function, this will be a from sum function. So this will be two separate values. There is a possibility that, actually not a possibility, we are copying the value of first A into the second A. So both are going to hold same value, but they are different. So what we can say is this A and B are local for main, and these A and B are local for sum. Okay, so these are the scopes of a variable. But when I talk about global variable, those global variables are accessible to all functions. They are accessible to all functions. So that's why they are not declared within any function. They are declared outside the function. Okay, it is not declared inside any of the functions. They are declared outside the function. And generally before main. Okay, so that all the other functions can make use of it, and all the other functions can alter them. Okay, it can be used everywhere. So that is a global variable. When we'll go into detail of that, the storage classes of mm, a variable when we'll learn, then we'll learn these things in detail. But right now, just understand there are two types of variables. Some variables which are working within the function, and some variables which are working in the entire program. So global variable and local variable. Because depending on that, the next discussion is uh, yeah. Now comes to the very important part of function programming. Okay, we are calling a function. So if this particular construct is used, that means we are calling a function. Okay, we are calling a function means there will be a calling function, there will be a called function. This called function may be of any type. Means it may take arguments or may not take arguments. It may return something or may not return something. It may have both the things, argument and return value. It may have any one of these things or it may not have anything. Okay. So when we call a function, we need to take care that what kind of definition is expected for that particular function. So in this case, if I am calling sum, it is expected that it must have two parameters and both the parameters must be an integer. It must uh, return a value. So we need to define a container which will hold that value, which will hold that value. So result is the container for it. So while calling a function, we need to be very clear about the declaration of the function. What all signature it is following. What all signature it is following. So that signature we need to follow. So here in this case, we are passing two arguments and returning one element. In this previous case, we are just passing two integer arguments and not returning anything. So this function calls need to be bothered. So, and see, remember we can call these functions number of times. We can call these functions anywhere in the calling program, and we can call these functions with any number of different arguments. So every time you call a function and you can provide a different set of arguments, set of parameters to operate on. So while doing that, we need to take care that how it should be called. There are two methods of calling it. Call by value and call by reference. So what we are doing in call by value, both the examples we'll have, just read it out. This method copies the actual value of an argument into the formal. What is the formal argument or formal parameter? The parameter which are defined with the definition of that function. Okay. So the formal argument is this one. Here A and B are formal arguments. These are the actual arguments. So A and B are actual arguments. These are the formal arguments. So the value of A will be copied, value of A and B will be copied in these formal arguments A and B. Okay. So the method copies, remember, method copies the actual value of an argument into the formal argument. So in this case, changes made to the parameter, means these parameters, the formal parameters inside the function have no effect on argument. So in this case, even if I'm changing A is equal to A minus 10 or A minus 5. So this change will not be permanent for this A, because only value of A is copied into A. Value of A is copied into A. So this value, this statement will not have any effect on this A, but if this A is further used, it is going to be affected. So in this case, this value is 10 and this value is 20. Value of A is copied in this A, value of B is copied in this A. Now A becomes 5. But which A? This A. Which A? This A, not this A. So A and B will change to 25. but this is not going to make any changes to this A value. So be very careful about this. It has no effect on the past argument or the past variable which is inside the main. There is a difference between global and local. We are making changes in the function, and formal parameters are local to the function. So it is not. It has nothing to do with the parameters in the argument. And second is call by reference. In this method, what we do, we don't copy the actual value, but we copy the address of an argument. Address of an argument in the formal parameter. So what we are directly accessing that variable. We are directly accessing that variable. So the address is used to access the actual event used in this call. This means changes made to the parameters will definitely affect the argument. So this is a big difference between these two calling. When we call by value, we just copy the value in the formal argument and make any changes in it is not going to affect the original value. But here we are passing the address, and all the changes will be made at that address. So whatever changes made at that address are going to get reflected in the actual argument. So the changes affect the argument. So choosing the method of calling depends on your requirement, whether you want to change those arguments or you want to keep them intact. Okay. By default, C will always use call by value to pass the argument. By default, it will consider it a call by value argument. So what and how exactly it will happen? How exactly it will happen? Now, what's happening over here? This is a call by value. It's my mistake. This is a call by value example, not so by mistake I have given the heading as this is not call by reference. Next example is call by reference. This is call by value. This is called by value. Okay. So what's happening here? We are trying to swap two values using a function. We are going to swap the values of two variables with the function swap. Just a moment. I'll just make a small change and we'll come back. Sorry. There was some mistake in the slide. That's why I made the changes and came back. We'll take the first example as call by value. This function, we are going to take the same example for both the cases, call by value and call by reference. So we are trying to swap the values of two variables using a function swap. Okay. So the function which is defined here by name swap, so is not returning in value and taking two integer variables as input. So taking two integer variables as input x and y. See, unlike previous example, in the previous example, we were just mentioning int. So that is also correct because this is just a declaration. And we are just informing compiler that there will be a function which will take two integers. Or you can declare them well in advance. The name of variables is not going to make any difference. So both the constructs are correct. So swap is a function which is taking two arguments, integer arguments, and returning one, returning nothing. Okay, it is not returning any value. A is defined as 100, B is defined as 100. At the after the output, I want that A should become 200 and B should become 100. So before swap, the values are printed as A and B. So it is just going to print it as before swap value of A is 100 and before swap value of B is 200. It is going to print something like that. Okay. And now we are trying to call a function. So this is a simple. Now what will happen? This A value will be copied in the value of X. Now X becomes 100. Then B value will be copied into Y. Okay, B value will be copied into Y. So Y will become 200. Now what you expect? What you expect that the values must be interchanged. Values must be interchanged. Value for A and B should be interchanged. This is our expectation from this program, right? So what will happen in this case? See here, a variable temp is taken, temp value is taken into X. So I'm not going to explain you the logic of swapping two variables. X value will be given to Y. So at this case, temp will become 100. In this case, X will become 200 and this value of temp will be given to 100. So what has happened? X will become 200 and Y will become 200. Sorry, Y will become 100. Okay, and now we'll return. So what you expect? What should be this value now? What it should print? What it should print? Can anyone answer? You can prompt in the chat box, or you can put your mic off and let me know the answer. What will be the output of this after swapping? What will be the value of A and what will be the value of B?
Value of A is 200 and value of B is 100.
Value of A is 200 and value of B is 100. Does everyone agree with this? Does everyone agree with this? Shreyas is not agreeing. Who answered the first one, please? Who answered the previous one? I could not see actually whose mic was on. Vedant. Okay. So Shreyash is not agreeing. Palash, what is the use of return in void statement? There is no use. We are just returning, making sure that the control is going to get returned to the proper place. Even if it is not used, that is not going to make any difference. Okay. So there is just return. These are the few things which will appear in the program. So here we are, as it is void, it is not returning anything. So that's simple. So yes, Shreyas doesn't agree with this. Can Shreyas explain that?
Sir, only the values are sent to swap function. That's why the original A and B value won't change.
Yes, 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 yes. We need to remember this. Again, I am repeating that only the values, actual values of an argument will be passed to the formal parameter. It has changes made to the parameter inside the function have no effect on the argument. In this case, what's the argument? In this case, the arguments are a and b, and formal parameters and x and y. So whatever changes we are making, we are making changes in x and y, which are within the function. So output will be 100 and 200. There will be no swap. There will be no swap. Okay. The a and b value will remain the same. It will not be changed. Right. I can, what at the max I can do is I can print it here as within the function. I can write, if I'm writing after swap value of a is x and value of b is y, at that time it will print that way, but that is not going to make any changes to the original value of a and b. Okay, original value of a and b will not be changed. We have called it by value. Only value of a will be copied in x, copied in x, and value of b will be copied in y. And now whatever changes are happening to x and y, which are not a and b. Okay, a and b will be created separately over here, which will hold some value. This is a, this is b. It is holding 200. This is holding 100. Okay, and then two more variables are created named as x and y. It will come in existence only when this function call starts. Okay, so what will happen? The actual argument, this a will be copied here, b will be copied here. Okay, because we have called it by value. Now value, once the values are copied, the things are over. Okay, there is no relation with a and b now. Whatever will happen with x and y. Whatever is happening here is happening with x and y, and there are no changes happening in a and b. Okay, so a, b remains intact, and the output you are going to get is 100 to 100. No value will be swapped. Okay, so I hope I made this point clear. But how we can make this happen? Because we want the values to be swapped. Okay, so it is possible using call by reference. Okay, what we are doing in call by reference, we are trying to pass the address of these arguments to the formal parameters. Now what will happen here, we'll see. Okay, this variable is declared. It should be pointer x and pointer y. It should be pointer x and pointer y, because it's the integer pointer variable which is which is going to collect the address. Okay, in the previous case they were collecting integers, now they are collecting address. The function is defined as swap, which is not returning any value and is taking two addresses of two integer variables as the parameters. So what will happen in this case? Now a is defined. A will be defined. B will be defined. Let us say that at location number 1000. This is at location number 2000. And value of A is 100. Value of B is 200. Okay. So after this is going to happen. Now before swap, value of A is 100. Before swap, value of B is 200. This we know. This we have initialized. Now calling the function swap. Swap with address of A and address of B. So it is not a normal variable, it's the address variable. So if it is an address variable, we need to have a pointer variable to collect it. If it is an address, we need to have a pointer variable to collect it. If it was float, we will have a float in there. Float formal argument. If it is character, we'll have a character formal argument. If we have an address, we have a pointer formal argument. So now what will happen? Address of A will be copied in X and address of B will be copied in Y. Now what will happen? Okay, there will be two variables constructed, pointer X and pointer Y. There will be two variables, correct? Pointer X and pointer Y. So they may have separate addresses. Let us say that it is stored at 500 and this is stored at 600. They are stored at 500 and 600. But what will be the values of this? X will be address of A. What is the address of A? Address of A is 1000. And Y will be address of B. So it will be 2000. It will not be 100, 200 anymore. It will be 1000, 2000 because they are the addresses of it. Got the difference of call by value and call by reference? In call by value, we are copying the value. In call by reference, we are copying the addresses. Now what will happen? What will happen? Temp will be equal to value at X. Temp will be equal to value at X. What is value at X? That is value at 1000 is 100. Temp will become 100. Now value at X, that is 100 is going to change to what? Y. So now X will become, value at A is, value at X is A. So A will become 200. Okay. Value at X is actually A. Value at 1000 is actually A. So A will become 200. Now value at B becomes temp. Temp is 100. So value at is B. So B will become 100. B will become 100. Okay. So now if now return control will come back here. We'll execute this statement, and now when I'll print A, it is going to print 200, and if I am printing B, it is going to print 100. Understood? Okay. So this is the difference between call by value and call by reference. Here we are passing the address and we are making all the changes in the address directly. So at 1000 we are making this. At 1000 whatever may be the value is going to get changed. Okay. And similarly, value at 2000 is also going to change to 100. Okay. So this is value call by value. Sorry, this is call by reference, and earlier was call by value. So there was no swap happened even if we change the values of X and Y, because the values were only copied, had no effect on actual argument. Here addresses were copied, that's why it will have a direct effect on the argument. So these are the two things which I wanted to tell you. So I hope I made the point clear. If anyone has any doubt, yes, as A and B are the main functional, so its value will remain same. Aditya has rightly answered the question which I asked. So any doubt by now? So I expect I made the thing clear, and tomorrow we'll see recursion. Okay, tomorrow we'll see recursions. Is an important lecture or important concept which will be used, and function will be over tomorrow. So if you have any doubts, you can ask, or if you need, the lecture is recorded. If you want, I can send you the link if you want to revise something. Okay. So if you don't have any doubts, you can leave the meeting. This is all from my side today. And if you have doubts, you can ask. I'm waiting.